A gilded room in the Tuileries Palace. Napoleon Bonaparte, Emperor of France, leans forward with genuine curiosity. He has just listened to a presentation on the universe's clockwork mechanics. Before him stands Pierre-Simon Laplace, the era's greatest mathematician. Napoleon poses a question that hangs in the air, simple yet seismic. He notes that the most celebrated works on the system of the world contain no mention of God. Laplace's reply, delivered without hesitation, echoes through the centuries. He had no need of that hypothesis. With those words, the divine architect was formally dismissed from the explanation of the cosmos. The universe was declared a self-sustaining machine. This was not just a scientific update, it was a declaration of independence. For the first time, physics claimed it could describe everything without invoking a designer. A universe running on its own, without oversight. And as physicists would soon discover, that universe contained a precision so exact, a tuning so delicate, that the silence Laplace left behind began to feel not like peace, but like a missing variable. Laplace's nebular hypothesis was elegant. A spinning cloud of gas, collapsing under its own gravity, flattening into a disk, planets condensing one by one, no divine hand required, just Newton's laws grinding forward across millions of years. And the model held. The planets orbit in the same direction, lie in roughly the same plane, the mathematics all consistent. Laplace had built something more than a theory. He had built a universe that ran like clockwork, a machine so precise that if you knew every particle's position and speed at a single moment, you could calculate the entire future of the cosmos. Determinism wasn't philosophy. It was a promise, but somewhere inside that perfect machine, a hairline crack was forming. A crack that wouldn't surface for another 100 years, and when it did, it would force physics to confront the very question Laplace had so confidently dismissed. If the fundamental constants of nature weren't inevitable, if they were instead precisely tuned to values that allow stars, planets, and living observers, then who or what set those values? For anyone wanting to dig into that question, I've written an ebook called The Physics of the Divine, exploring fine-tuning, consciousness, and the quest for God. It walks through exactly how modern physics keeps stumbling over these unexplained parameters: the cosmological constant, the strength of gravity, the mass of the electron, numbers that appear in our equations with no derivation, no reason, just values that happen to permit everything we see. The link is in the description below, and the first crack appeared in 1917. Einstein, applying his brand new general relativity to the entire universe, found that his own equations wouldn't allow a static cosmos. Matter would either collapse inward or fly apart. So he introduced a mathematical fudge factor, the cosmological constant, a force that would hold everything perfectly in balance. The universe could be eternal and unchanging. 12 years later, Edwin Hubble pointed a telescope at distant galaxies and proved the universe was expanding. Einstein's static model collapsed. He called the cosmological constant his greatest mistake. But mistakes in physics have a way of returning. For 80 years, the cosmological constant sat in the graveyard of physics. Mentioning it at conferences was a quick way to get strange looks. Einstein's blunder had become a cautionary tale, proof that even genius could stumble when vanity replaced evidence. The universe was expanding. That was settled. Every telescope, every measurement, every calculation confirmed it. The story was plain, the ending written. Then, in 1998, two independent teams of astronomers, one led by Saul Perlmutter at Lawrence Berkeley, the other by Brian Schmidt and Adam Rees at the Mount Stromlo Observatory in Australia, began measuring something no one had thought to check with precision. They were observing Type Ia supernovae, stellar explosions so bright they outshine entire galaxies, using them as cosmic mile markers to measure how fast the universe's expansion was changing over billions of years. The expectation was simple: gravity should be slowing the expansion down. The universe was decelerating. It had to be. It wasn't. The supernovae were dimmer than expected, farther away than their redshifts predicted. The expansion wasn't slowing. It was speeding up. Something was pushing the universe apart against the pull of all its own gravity. Something without a name, something that behaved exactly like Einstein's thrown-away constant. And here is where the crisis truly begins. Quantum field theory, our most successful framework for describing the subatomic world, predicts that empty space is not empty. It seethes with virtual particles flickering in and out of existence, each contributing a tiny amount of energy to the vacuum. When physicists calculate that vacuum energy and compare it to the value of the cosmological constant we actually observe, the discrepancy is not a factor of 2, not a factor of 1,000,000. It is 120 orders of magnitude. A 1 followed by 120 zeros. It has been called the worst theoretical prediction in the history of physics. The numbers do not merely disagree, they exist in different universes. And yet, that impossibly small observed value, so delicate, so specific, is exactly what allows galaxies to form, stars to burn, and matter to coalesce into structures complex enough to produce minds capable of noticing the discrepancy. Change it by even a fraction, and the cosmos becomes a featureless void. The constant that refused to die turns out to be precisely calibrated for life. No one knows why. The cosmological constant is one number, one dial on an instrument of incomprehensible complexity. But what happens when you realize there are dozens of other dials, each one set to a value that seems just as impossible, just as surgically precise? Consider gravity. If it were stronger by 1 part in 10 to the 39th, that is a 1 followed by 39 zeros. Stars would burn so hot and fast that complex chemistry would never have time to develop. Life requires slow-burning stars, billions of years to forge carbon and oxygen in their cores. Make gravity slightly weaker and stars never ignite at all. The universe remains cold, dark, and dead. The margin here is not generous. It is a razor's edge stretched across an ocean. Then there is the strong nuclear force, the binding energy that holds atomic nuclei together. Increase it by 2% and stable atoms beyond hydrogen become impossible. No carbon, no oxygen, no periodic table as we know it. Decrease it by 5% and the only element that survives is hydrogen. No stars could form the heavy elements that planets and people require. 2% in one direction, 5% in the other. Everything else is forbidden. The weak nuclear force, which governs how particles decay, controls the ratio of hydrogen to helium produced in the early universe. Alter it and stars either exhaust their fuel too quickly or never begin fusion at all. The mass of the neutron relative to the proton, if the neutron were even slightly heavier, protons would decay and hydrogen would vanish. If slightly lighter, protons would convert to neutrons and again, hydrogen disappears. No hydrogen means no water, no stars, no chemistry. These are not independent accidents. They are interlocking. Each constant constrains the others. Change one and you must recalibrate all the rest, or abandon the possibility of a life-permitting universe entirely. Physicists have mapped these dependencies across dozens of parameters, and the pattern that emerges is not comfort. It is vertigo. The recipe for a cosmos that produces observers appears to occupy a sliver of possibility space so thin it defies intuition. The anthropic principle offers a seductive escape. We observe a fine-tuned universe because only a fine-tuned universe could produce observers to do the observing. It is tautologically true. But it explains nothing. It tells you why you cannot find yourself in a dead universe. It does not tell you why a living one exists at all. And this is the question that Laplace thought he had buried, the question that keeps resurfacing in the data, in the equations, in the staggering improbability of every constant that makes your existence possible. Is this precision the result of blind chance, of a multiverse so vast that every combination eventually appears, or is it evidence of something deliberate? If you want to explore that question further, the full landscape of fine-tuning, from cosmological constants to the structure of consciousness itself, I've written an ebook called The Physics of the Divine, exploring fine-tuning, consciousness, and the quest for God. It walks through the evidence on every side, no conclusions forced, just the deepest questions physics has produced. The link is in the description below. What we know is this: Laplace removed God from the equations. 160 years later, The equations keep requiring something Laplace never accounted for, a set of values so precisely chosen that the universe they produce seems less like an accident and more like an answer to a question no one remembers asking. In the spring of 1953, Fred Hoyle sat in his office at Cambridge, staring at a number that refused to behave. He had spent months tracing how carbon atoms form inside dying stars, and every pathway led to the same bottleneck. Carbon-12 has a specific energy level in its nucleus. Change it by a fraction of a percent and carbon cannot accumulate. Stars would produce helium and oxygen, skipping carbon entirely. Life becomes chemically impossible. Hoyle did not believe in God. He had said so publicly, repeatedly, with the confidence of a man who considered the question settled. But when he ran those numbers, something shifted. The precision required was so extreme that he later wrote it looked like someone had monkeyed with physics. He meant it literally. A superintellect, he said, had fine-tuned the universe to produce carbon. He never recanted. Here is the intellectual trap that fine-tuning creates. When we encounter improbable conditions producing a specific outcome, a locked door, a loaded die, a forgery, we infer design. We do this instinctively. If you found a watch on a barren beach, you would not assume the wind assembled it, but apply that same inference to the cosmos and you collide with a wall. That wall has a name: methodological naturalism. It is the working rule that scientific explanations must appeal to natural causes, not supernatural ones. It is not a claim about what exists. It is a boundary on what counts as science. And that boundary means that even if the universe appears designed, science is structurally prohibited from concluding that it is. The designer hypothesis is, by definition, untestable. But the data does not go away because the rules forbid a particular interpretation. The fine-tuning is measured, the improbabilities are calculated, and the question Laplace thought he had exorcised keeps returning, not as theology, but as a variable in the equations themselves. Science removed God from physics in 1859. Physics, it seems, is not finished with the question. But if the question keeps returning, physics needs an answer that stays within the boundaries Laplace drew. The escape hatch came from the very theory meant to unify physics itself. Leonard Susskind spent decades at Stanford chasing a single elegant equation. Instead, he found something else. String theory does not predict one universe. It predicts roughly 10 to the 500th power of them, each with different constants, different physics. The string theory landscape is not one answer. It is an ocean of answers, most of them dead. Here is the move that changes everything. If that many universes exist, every possible combination of constants has been tried. Universes where gravity crushes matter in seconds sit beside universes where chemistry never begins. And somewhere in a vanishing fraction, the constants align. Carbon forms, stars endure. Life appears not because someone set the dials, but because all dials were turned eventually, and we happen to live where one combination worked. This is anthropic selection. We observe a fine-tuned universe because only a fine-tuned universe could produce observers. The question answers itself, but there is a problem. The multiverse cannot be tested. No experiment reaches beyond our observable universe to confirm others exist. It makes no unique prediction distinguishing it from a designed universe. For many physicists, being unfalsifiable disqualifies it from science, and there is a deeper cost. If everything possible exists, then our universe's specific structure carries no more meaning than a lottery ticket from an infinite pile. The precision of the constants becomes statistical inevitability rather than remarkable fact. It does not answer why, it dissolves the question. If you want to explore the full debate, the landscape, the philosophical costs, the arguments on every side, I've written an ebook called The Physics of the Divine. It examines whether fine-tuning points to intelligent design or can be explained by materialist theories like the multiverse. The link is in the description below. The multiverse gambit preserves naturalism and avoids the designer, but it asks you to accept an unobservable infinity of universes to explain the one we have. Whether that counts as explanation or postponement depends on what you think science is supposed to do. A detector sits in a darkened laboratory, waiting. An electron approaches a barrier it has no classical right to cross. There is no opening, no tunnel, no door. But the electron passes through anyway, not because it had enough energy, but because the mathematics says probability never truly reaches zero. The experiment runs millions of times. Each time the electron has a chance, and each time someone is there to record the result. This is where the multiverse explanation meets its limit, because there is another phenomenon physics cannot dismiss. The same universe that requires impossibly precise constants also produces minds capable of asking why those constants are precise. And the relationship between those minds and the physical world is not as clean as Laplace assumed. Eugene Wigner spent his career at Princeton winning a Nobel Prize for work on symmetry in particle physics. He was not a mystic. He was one of the most rigorous mathematical physicists of the 20th century. But late at night, working through the implications of quantum mechanics, he arrived at a conclusion that unsettled him. The act of measurement, the moment a quantum system transitions from possibility to actuality, seemed to require something more than a physical interaction. It seemed to require an observer. Consciousness, Wigner argued, was not a byproduct of physics. It was woven into the equations themselves. This is not fringe thinking. The measurement problem is real. Quantum systems exist in superpositions, multiple states simultaneously, until they are observed. What counts as an observation remains genuinely unresolved. Is it any interaction with a detector? Does it require a complex system, or does it require a conscious mind? The physics does not yet answer this, and here is the deeper problem consciousness creates for materialism. Physics can describe what neurons do. It can map the electrical storms of thought. But it cannot explain why there is something it is like to experience red, to taste salt, to feel the weight of an unfinished question. Philosophers call this the hard problem. No arrangement of particles, no matter how complex, logically requires that subjective experience emerge from it. If consciousness cannot be reduced to physics, but physics seems to depend on consciousness for its outcomes, then mind might not sit inside the universe the way matter does. It might sit beneath it. The same variable Laplace removed keeps finding new ways back in, not through equations, but through the simple, undeniable fact that someone is here to write them. The Large Hadron Collider cost $10 billion. It stretches 27 kilometers beneath the Franco-Swiss border, the most expensive instrument humanity has ever built to find the answer. It did not find it. For decades, physicists have pursued theories that might close the gap. Supersymmetry predicted partner particles for every known particle, a mirror doubling that would stabilize the equations. The collider found nothing. Modified gravity proposed that Newton and Einstein were incomplete at cosmic scales, that gravity itself changed behavior across billions of light years. No observation confirmed it. Quintessence suggested the cosmological constant was not constant, but a dynamic field, shifting across time. Measurements show no such variation. Each theory carried genuine mathematical elegance. Each made predictions that could have been tested. None survived contact with experiment, and this is the humbling core of where physics stands today. The fine-tuning remains. The cosmological constant problem remains. The hard problem of consciousness remains. We have built theories to explain them away, the multiverse, symmetry arguments, emergent consciousness, and every one of them either asks us to accept what cannot be observed or assumes what it sets out to prove. Laplace removed God from his equations in 1859 because he saw no need for the hypothesis. 2 centuries later, the equations still carry terms no one can derive from first principles. The constants remain fixed at values that permit neither explanation nor variation. The observer sits inside the system, staring back at the mathematics that describes them, asking how any of it was possible. Perhaps the hypothesis was never removed. Perhaps it was only deferred. If this exploration gave you something to think about, a new angle on an old question, or a problem you had not considered, I would genuinely love to hear your thoughts in the comments. What do you think physics is missing? Where does the boundary between explanation and mystery actually sit? I read every response, and conversations like these are the reason I make these videos. The full journey from fine-tuning through consciousness to the question of design is laid out in detail in the physics of the divine. It walks through the evidence, the arguments, and the honest uncertainties, so you can form your own perspective on whether the cosmos points towards something beyond itself. The link is in the description below if you want to continue the conversation there. There is a line, invisible, unmapped, beyond which equations stop predicting and questions simply remain. Physicists cross it every day. They write theories that work to 10 decimal places, then stare at the one term that will not simplify, the one constant that refuses to explain itself. We have spent this journey tracing that line. From Laplace's confidence that God could be subtracted from the cosmos, through the discovery that the universe is fine-tuned to an almost impossible degree, to the unsettling realization that consciousness might not sit inside physics, but beneath it. Each step forward revealed a deeper gap in understanding, not a smaller one, and here is what that pattern suggests. Science is extraordinarily powerful at answering how. How does gravity curve space-time? How do particles tunnel through barriers? How did the universe expand from an initial singularity? These are questions with methods, with experiments, with mathematics that converges on an answer. But science has limits, not temporary limits that dissolve with better instruments, but structural ones. The question why the universe exists at all may not be answerable from inside the universe. The question why the constants are what they are may require a framework that no experiment can provide. These are the places where physics ends and philosophy begins, not as a failure of science, but as a recognition of where its proper boundary lies. There is beauty in that boundary. Not every mystery needs to be solved to be meaningful. Some questions exist precisely so we keep looking, keep wondering, keep holding both doubt and wonder in the same hand without collapsing into certainty on either side. If you have watched this far, you are someone who does not need easy answers. You are someone who would rather sit with a profound question than accept a shallow one. That instinct, the willingness to remain at the edge of knowing, is rarer and more valuable than you might think. Thank you for being here. Write a comment telling me which moment in this journey changed how you see the universe. I read every response, and yours might be the one that shifts someone else's thinking. A page of equations carefully inked, every term accounted for, every variable simplified, except one. In the corner, a constant, stubbornly equal to a value no theory can derive. A value that permits the existence of stars, of planets, of the hand that wrote the page. 2 centuries ago, Pierre Simon Laplace stood before Napoleon and declared he had no need for that hypothesis. His celestial mechanics worked without it. For a time, that seemed like the final word. God was a variable science had successfully subtracted from the cosmos, but the cosmos had more surprises. As our instruments grew sharper, we found the universe was not just running on equations, but on a razor's edge. The cosmological constant, what we might call the energy density of empty space, was not the zero we expected, but a number so delicately poised that a nudge of 1 part in 10 to the power of 120 would have torn the cosmos apart before it could form a single atom. This is the cosmological constant problem. It is not a detail. It is a chasm in our understanding, and this chasm led us to a deeper one. Every fundamental force, every particle mass, appears tuned with impossible precision. Change them by a fraction, and chemistry, stars, and life become impossible. This fine-tuning is not a theory, it is a measurement. It is a fact staring back at us from the data, and here we stand. Laplace removed God because the math worked without him. Now, the math includes a term for which we have no explanation, surrounded by a fine-tuning that resists every materialist attempt to dissolve it. The variable was not eliminated, it was deferred, and now it returns, wearing the language of constants and probabilities. If you wish to walk this boundary further, to examine the evidence for and against design, to sit with the intersection of physics and meaning, the full journey is explored in the physics of the divine. It is a companion for this very question, and the link is in the description. We have no final answer, Only the equation, with its one unsolved term, and the vast, quiet universe it permits. The question remains,